Good morning, everybody. This talk is going to be in two halves. I'll have a break in the middle when people can ask questions. I don't really mind being interrupted if something isn't clear. And at half time, we'll have some questions, and I will also ask you a question before the second half, because how I do the second half depends on the sort of answers people give me there, how much detail to go into and which bits to do. Okay, it's a fairly long talk, so I will get on with it. Okay, these are the two practical publications that I'm going to talk to tonight, and these were booklets that were written for the Welsh Beekeepers Association. The first, they're both second editions, and the first of these was written in 2010, and a couple of years after, I think I wrote this one, something like that. And these get distributed free to all the members of the Welsh Beekeepers Association, which is about 1,800 people. And the first editions actually were financed by the Welsh government, but they've been a bit tighter with their finances in recent years. But we manage it fine to do it on the funds of the association. And then more recently, after a long gestation period, at least inside my head, this is the book I published last year through the magazine BeeCraft. And this was written because we had over a number of years tried to understand the biology behind swarming and how the colony organized this, the most important event in their life cycle. So about 60% of the book is actually about the biology of swarming, which I find useful in the beekeeping. A lot of people just want fairly prescriptive instructions about who to do things. So the booklets are all of that type. They have text and they have diagrams to explain all different manipulations, color-coded diagrams. So, right, okay, so what is swarming? Well, I'm sure you all know that. It's simply reproduction, and it's the colony's sole aim in life. Everything that the colony does is to maximize the chances of being able to reproduce successfully. And this famous book by Celia and Morse, Bait Hives for Honey, they make it quite clear what the colonies do and say mature colonies have a natural urge to swarm each year unless they are weakened by disease or mismanagement. So we should not be surprised if colonies swarm. Certainly the beekeeping books written and published in the UK really understate swarming. They kind of give the impression that if you've managed your bees and they swarm, then you're not a very good beekeeper. And beekeepers tend to do the same. When we first took up beekeeping, had trouble with swarming, we started to ask other beekeepers, have you got trouble with swarming? And they say, no. And we quickly discovered they didn't actually know what their colonies had done, or some of them were being fairly economical with the truth. We have quite a few beekeepers who at that time, anyway, I hope they're a bit better now, would perhaps only go into their colonies a few times a year, and probably we have beekeepers who've never went into the brood nest at all. They weren't interested in that part. They were just interested in the honey supers. So I recognise that beekeeping is a fairly broad church, and there's a range of opinions about swarm control. And there are people who think that trying to control swarming in the honeybees is not good. They should allow them to behave naturally. Others practice intensive swarm control. And still other people, I mean, commercial beekeepers with large numbers of hives just do not have the time to do intensive swarm control, in the sense that they will actually look for colonies starting to swarm and do something about it, but they will engage in management to try and prevent the colonies getting into the condition when they are ready to swarm. And I don't think there's any moral imperative about swarm control. It is just, the imperative really is the welfare of the bees being sufficiently apicentric to put their needs first. And this is opposed to anthropocentric, when we put our own interests as beekeepers first. People have to have the time to do this, and it does, to do it thoroughly, it does take time. But if you enjoy your bees, you're perhaps willing to do this. So the main reason to practice swarm control is the main aim of most beekeepers, and that's to produce a good honey crop, reliably produce a good honey crop. If you lose a prime swarm, certainly in our fairly short season, that may be half the crop gone. If you lose after swarms, that's still more gone. I mean, each time there's a swarm, the number of bees in your colony roughly halves. So your foraging force is diminishing rapidly. And when you lose a swarm, you're also losing a perfectly good laying queen. And there's always a chance that the colony may fail to requeen if there's some bad weather at the time or something. The queen may not get mated properly. You may actually have to do something else to requeen the colony. If you live in an urban area, losing swarms can be a problem. And quite honestly, the shorter the season, the more important is swarm control. We actually have a relatively short season compared with you, probably. I mean, our colonies are absolutely tiny at the minute. Some of them, I doubt that they've got a cluster much bigger than a large grapefruit, and it's amazing how come the end of next month they will start to build, and by the beginning of May they will be quite large. So the implication of not practicing swarm control are that you may not get much of a honey crop, and you may lose a functioning queen. Colony may not requeen. You can cause a public nuisance. Now, I gather you do have problems with civil authorities making rules and regulations about your beekeeping. That does not happen here. I've heard very few cases where civil authorities have intervened in any way about people keeping bees. That they're really just answerable to their neighbours if there are any problems. I mean, the upside of losing swarms is that it's more apicentric, and it restocks wild bee nests, and these are subject to natural selection. And it's also a lot less work. Throughout the whole business of varroa, we have always had feral colonies around the place. People said that they all disappeared, but certainly where we are, they didn't. So I would like to get the terminology of swarm control clearer, because it's often very confusing in books and articles. But swarming does have a biological threshold, and that point, the point of no return, if you like, is when queen cells have been started, when you see charged queen cells in your hive. And you're noting here, I've said, or is it? And I will come back to that. Bear that in mind. I will come back to that. As far as the beekeeper is concerned, that is the point of no return. So what I've used in my own writing is to make clear the terminology, is preemptive swarm control, and this is what the beekeeper can do before queen cells are present to try and prevent their initiation. And reactive swarm control is what the beekeeper can do when queen cells are produced and to prevent the loss of swarms. And preemptive swarm control is going to form the first part of this talk, and reactive swarm control the second part. So you need to understand the basic problem you've got with swarming and what the beekeeper is up against when trying to practice preemptive swarm control. I'm sure you all realize that in the wild that the colony had to choose a nest site for itself. Its optimum size would be about 40 litres volume. And this has been very elegantly shown in a series of experiments by Tom Seeley. And well, our national deep box is about 35 litres, and I think the Langstroth deep box is very similar. So this 40 litres is the space that the colony regards as being adequate to produce whole life cycles. And the aim of the colony each year is to fill it with bees and brood and stores in as early in the season as possible. And when it has achieved this, it's time to swarm. So this is what you're up against now. And then after swarming, the colony gets a new queen, rebuilds, and accumulates stores for the winter. At least that is the system in our fairly short season. But I think you may have a second peak of swarming in the autumn in some areas. So how do people interfere with this strategy of the bees themselves? They provide an increasing amount of space for brood and honey. They induce the colony to draw new combs because this is a sign of immaturity to them. And we can remove or relocate brood. All these are attempts to simulate brood nest immaturity. And of course, it only became possible with the movable frame hive, a modular beehive. So the above forms of management all constitute what I call preemptive swarm control. And basically, it's a con trick on the bees that works in some seasons and not in others. We've just gone through a season where in our own 35 hives, only 3 of them attempted to produce queen cells, and one of those actually turned out to be, we made a mistake. It wasn't an attempt to swarm, it was an attempt to supersede. And the other 2 were actually genuine attempts. This was a good year. 2018, every hive that was big enough, which is roughly 80% of our hives, produced queen cells at least once in the season, and some of them did it twice. It is quite dependent on the season how successful you are. So when your preemptive swarm control fails, and as I've said here, you can fool some of the bees some of the time, but you can't fool them all of the time. When queen cells are started, you need to move on. Preemptive swarm control has failed. You need to go to reactive swarm control. And these are totally different techniques involved in reactive swarm control. But in the literature, they're often very confused. What you do now comes under the general heading of artificial swarming. And what it says in the books is that artificial swarming is supposed to work by making the colony think it has already swarmed. This is discussed in the biology in the book. I don't actually believe it's possible to do this. I don't think you could, any management you do actually does persuade the colony is a swarm. There are other mechanisms involved in successful artificial swarming. And the method that I'm going to describe in this book, which we developed over a number of years by trial and error, quite a lot of errors, is a completely different thing. It is attempt to persuade the colony it has a prior agenda other than swarming. And this method is, we have called, possibly unwisely, Snellgrove 2 modified. It's a modification of a method of artificial swarming developed by a very, very clever beekeeper who actually wrote the first edition of his book in 1934. And he was a wonderful observer, and he tried all sorts of different things, but he didn't have the advantage was that bee science was in a much poorer developed state in those days, so there's a lot of information he didn't have. Okay, the signs that when preemptive control fails, when you see queen cups with contents, and this is, to say, the biological threshold, point of no return. It's not when you see drone brood in a colony. People say, oh, yes, okay. There's drone brood now. They'll set up the swarm shortly. Well, there are lots of colonies that have drone brood all season. Drone brood is just a second way by which the colony passes its genes on. The odds of any one particular drone managing to pass its genes on is very low, but collectively there are many of them. A colony actually has an equal chance of passing on its genes through the drones it produces. It does actually through swarming. And when there are drones in the colony, it doesn't mean the colony is going to swarm. It just is that the colony has got in a state of development where it feels it can support these drones. And similarly with queen cups, it's just a stage in development during the season of the colony. They got to the stage now when they might want to swarm, so they start to build queen cups. And one of the mysteries is, and we've noted this over the years, that if you look at the queen cups, you will often see the odd cup with a standing up egg in it. And this is not a sign the colony is going to swarm necessarily. They can go through the whole season producing standing up eggs from time to time and never make any attempt, never go the next stage further of allowing that egg to hatch and start to be fed royal jelly. But when you've got cups with contents, that's when you need to swap to reactive swarm control. So I'm going back now to this question is, when you see cup with contents, is it the true start of swarming? Well, as far as the beekeeper is concerned, what he can see, it is. However, there is evidence from observation hives, and this work was done at University of Georgia, I think, by a gentleman called Stanley Snyder and his postgraduates there. And about a fortnight, what they were studying was the use of various signals inside a colony. And what they found was that about a fortnight before queen cells are produced, the behavior towards the queen changes, and the workers start to subject to what is called the vibration signal. And this signal consists of a worker bee grabbing her and shaking her for a second or two. And this vibration goes on with increasing frequency, And during this period, which lasts about a fortnight, she is also fed more. The result of this is that she goes into overdrive laying eggs. So she lays a hell lot of eggs during this period. But just before the queen cells are actually produced, this signal stops completely. And the purpose of this behavior is to provide a large cohort of young bees that will emerge over the next 3 or 4 weeks. Now, what happens next? When the queen cells are present, the vibration signal starts up again. And again, with increasing frequency up until just before the swarm issues. During this period, the queen is fed less and kept on the move. And the purpose of this is to slim her down in preparation for flight. So you can now see this is a coordinated plan to ensure the success of swarming, which actually lasts for about 3 weeks, not simply just the 8 days between the start of a queen cell and the actual issue of a swarm. So it goes on much longer, and this is part of an integrated program to maximize their chance of success. We have wondered whether, in fact, this was a complete decision to swarm, but it does not seem to be. It can be switched off. Of course, the beekeeper has no idea of telling it if it even in progress, because you can't observe this behavior. Of course, the moment you go in the hive, any sort of behavior like this is disturbed. You can't see it happening. But what we have discovered over the year, what we try to do with most of our colonies is to judge when they're getting up to the sort of stage of development they're going to swarm, and split them, preemptive splitting, which we discuss further later on in this talk. And what we've discovered, that colonies to which we have done this, split them, do not, very rarely will go on to produce queen cells in less than a month or 6 weeks. So obviously some of these colonies must have been in this sort of latent swarming period, as we call it, at the time we split them. But the fact that we split them does just stop the process. It puts a halt to it. Right, now this is one of the really important questions about understanding swarming, and that is the composition of the prime swarm. I don't know what is in your books, but our books say that the prime swarm is composed of the old queen plus the flying bees, and these obviously are the older bees. If this is the way you have understood what a prime swarm is, then it's completely wrong, because the prime swarm is actually dominated by young bees, and typically 70% of these bees in the swarm are under 10 days old. And this includes bees down to less than 4 days old. In fact, there's one of the early bee books in Britain by a gentleman called E.B. Wedmore. He actually said something different from everybody else. He said that a swarm consisted of all ages of bees, and he noted that occasionally when a swarm issued, some of the bees that came out of it were so young that they were actually incapable of flight and perished on the ground. So this just shows what they're really going for. And the work on this was actually done just before the Second World War at a famous bee research station called Rothamsted. And was the article showing what the composition of the swarm was actually in publication in 1940. So in our country, it's only just beginning to become accepted by some people that the swarm doesn't consist of the queen and old bees. You need to remember this when it comes to artificial swarming, because the explanation for artificial swarming is that the artificial swarm that's made by the traditional method thinks it's a swarm, but of course it's got the completely wrong composition of bees to think it's swarmed. So now I'm going to go on to preemptive swarm control, and I think you'll all be fairly familiar with preemptive swarm control. This, because much of this is just good management of your hives. So this is what we're attempting to prevent. Here's a colony with plenty of queen cells right across the way. This is we normally keep our bees on a 2-box system. So when we have done the comb management period, usually completed by the end of May, we're not going to change any combs, not going to put any more foundation in the hive. We will just check for queen cells by taking the supers off and just turning the upper brood box on its side like this, so you can view the underside, and you run smoke over it to clear the bees. And that is almost completely reliable method of checking whether there are queen cells in the colony. If there are none on these bottom bars here, then it's extremely unlikely to be any queen cells anywhere else. And it only takes a few moments to do this and doesn't necessitate you taking out lots of frames. So some of these preemptive management is really multi-purpose. It's just good beekeeping. And the aims of it are to promote a large colony that's capable of collecting a large crop of honey. And the main thing here that is involved is systematic renewal of brood combs. Reading the book on Californian beekeeping by Jeremy Rose that Jerry sent me, I see that he said that you do not replace brood combs as often as we do. We are supposed to, and we do it. We actually change our brood combs on roughly a 4-year cycle. It doesn't mean that every comb is taken out after it's 4 years old, and a lot are taken out before because they have some defect or have been very heavily used. So we are actually changing about 1/3 of our combs each year, our brood combs each year in the colony. And this is actually a very successful process in preventing the 2 main brood diseases. And also the comb management allows you to make queen replacement if you want to, and also make extra colonies if that's what you want to do. So honey production is the primary aim of most beekeepers. And to produce large crops, you need to have a large colony, so the ratio of foraging strength to the colony overheads is favourable. So unless nectar flows are predictable and time limited, which they certainly aren't in the UK, there may be a bit more with you, I don't know. You need to maintain that colony. We need to maintain a large colony for 3 to 4 months. But of course, the larger the colony and the longer it is in that condition, the more likely it is to set up to swarm. So if you like, preemptive swarm management is what you might call a catch-22. You're actually increasing the probability of something you're trying to stop. So we suggest that a beekeeper, these are the 5 strategies that we suggest that a beekeeper can adopt. And we really try and adopt a combination of strategies 1 and 2. In other words, you can try and keep the colony together for the whole season. And that will, if you're successful, that will get you the best crop of honey that is possible in that season. But if you fail and it sets up the swarm, then you have to resort to colonies 3 or 4. But we also mix this with strategy 2, which is splitting the colony at a carefully chosen point in the season. For us, that is usually at the end of May, because by that time we have had the spring flow of honey mostly from trees and shrubs, and it's a good time to split the colony. In some areas, we then have a period when there isn't much forage. It varies on quite a small scale locally. We have 3 miles down the road, we get a good flow in early June, which we don't get here where we are. Another strategy is to wait until queen cells are present and then do an artificial swarm. And this probably results in a reduced crop, but it depends very much on when the queen cells are produced, what point in the season they are produced. The old way, when people before movable frame beehives, was to allow colonists to swarm, and catch the swarms, get them in a hive, and prevent the colony from issuing cast swarms. And this can produce a good crop. And if the swarm if finally you can catch the swarm and it occurs early in the seasons, you can take advantage of the high vigor of swarms, which are able to establish very quickly and build up to a stage when they can produce a significant amount of honey. And finally, there's let alone beekeeping. A lot of beekeepers do just this. They just add supers early in the season and hope that they will get a crop. And some years they get lucky. But if they don't do any brood management, it's unlikely they'll get a really good crop. And it's always best to decide on what strategies you are going to deploy during the season, because you have to have the necessary equipment, boxes, frames, to hand to actually do it. It's no good think, oh, I wish I got some frames, I could split this colony. You've got to have that ready and available at the time you need to do it. This is one way of dealing with strategies 4 and 5, and we had a very interesting talk, virtual talk from a very good commercial beekeeper in Britain. He was talking about his swarm control, and his swarm control was entirely preemptive. He managed his colonies, the co-management of his colonies was to try and prevent them producing swarm cells, but he knew perfectly well that some of them would. So in all his apiaries, he had catch hives like this in different places, that when he failed and swarms were issued, he stood a very good chance of catching them. So this is one. This is actually our association has a training apiary, and this catch hive is about 100 meters from the training apiary, which is just a good distance to catch swarms, and it has caught several swarms. Although ironically, none of the swarms it's caught are actually from that apiary. It's caught just passing swarms. So the triggers for swarming are a mixture of internal and external conditions. So the internal ones are to do with the size of the colony and the space for the queen to lay, the brood nest maturity, and the age of the queen. Although we have not found the age of the queen to be terribly important. We actually have queens that we expect to last a minimum of 3 years. Many of them actually go on to a 4th year, and we've recently had a queen that just crept her way into the 6th year of her life before she was superseded. You need to leave space for nectar processing and honey storage, and production and distribution of queen substance is thought to be the main mechanism that leads to swarming. Although down the years there have been a number of attempts to provide colonies with a supplement of queen substance in order to prevent them swarming, and none of these have actually proved to be successful. For what reason, I don't think is fully understood. The external conditions are the time in the season, because colonies have an urge to swarm during the period when they're most likely to be successful, and with us that is May and June. So the swarming urge is at its peak during those 2 months. Also, weather is an underrated factor. For us, what we mean is that we get periods during our summer when the jet stream is in the wrong position in relation to the British Isles, and a series of low pressure areas rush across the Atlantic, bringing periods of wind and rain. And these can actually go on for more than a week. And we are aware that at the end of these, we will open our hives and find that some of them are set up to swarm. They seem to think this is a good time to do this. So what beekeeping can do, we can to some extent control the internal conditions through the management of the hive, and particularly the management of the brood area. But we can do absolutely nothing about the time of year and the weather. So these are what I call the weapons that are available for preemptive swarm control. These are the main management techniques by which we control in the internal conditions of the hive. First of all, comb management, and then there's box management. I will explain what I mean about that. Brood relocation, and so with these three, you kept the colony in one piece. But with the fourth option, which is the really powerful one, splitting colonies, you've actually divided the colony. I don't know what you people do about queen clipping. It is regarded as the sign of a good beekeeper in the UK that everybody who really takes beekeeping seriously ought to clip their queen's wings. We do not do this, never have done. All it does is it does not prevent initiation of swarm starts. It has nothing to do with it. It just causes the prime swarm to abort, but the colony will still swarm with when the first virgin queen emerges. What happens is the colony will swarm with a clipped queen, but she will fall to the ground, and eventually the bees will give her up in disgust and go back home. And this does happen naturally from time to time, by the way. We've had, on several occasions, we've had colonies with a queen who looked perfectly capable of flight, but did not appear to be able to fly, or was not willing to fly. You just don't know. And you get this curious situation where the colony has lost, you go in the colony and it's the same size you expected it to be, but you look through it and there is no evidence of laying queen. In other words, there are no eggs there. And the age of the youngest brood tells you when this abortive swarm took place. But you have to do something now because the first virgin will emerge. They will swarm with her. I mean, the downside of wing clipping, if you let it, if you use it to, the aim of it is to extend your necessary period for doing hive inspections from 7 to about 14 days, because if it does swarm and they lose the old queen, it takes them that long to get for the first virgin usually to do another swarm. What you've done if you let this run is that you lose the valuable existing queen, and that colony will not have another queen for 4 to 6 weeks. It can be adaptive for use of honey production to adopt strategy for and actually allow the colony to swarm. It can be a very good way of dealing with colonies, but you just have to ensure you catch the swarm. So comb management, the aim here is to ensure that most of the combs in the brood area are actually used for brood rearing. So your aim is to minimize the storage of honey and pollen in the brood area. You remove frames that are not being used to their full potential and replace them. You get new combs drawn. The use of foundation and drawing comb simulates brood nest immaturity and delays swarming. This process of changing combs should actually start in the autumn of the previous season, when before you feed the colonies, you put the old combs towards the outside of the nest, so that when the next season starts up and you want to start replacing combs, they won't have any useful contents. It's not possible to always do it, but it makes a good start to changing the combs. I've discovered that beekeepers do not really understand comb drawing very well. And you must realize that when you put foundation in a colony, they will only draw it if they have an immediate use for the comb to extend the brood nest or for storage. A bee colony does not undertake speculative comb building. It won't build comb so with the later in the season in mind. It must be an immediate demand to use this comb, and there must also be a nectar flow, or the beekeeper must provide one by feeding syrup to get comb drawn, because bees do not use stores honey for wax making. They will always, the wax making bees will always come down to the lower part of the hives to refuel from incoming foragers. And you have to understand how important this is, because making wax and drawing comb is an expensive activity for the colony. They say a pound of wax takes 8 pounds of honey. There are also other things. You're also diverting bees from other tasks, and in the area where they're drawing comb, there has to be a local increase of temperature to about 42 degrees centigrade, which is the temperature at which beeswax becomes very malleable. So use of foundation brood boxes, introductory foundation should be done at the right time in the right position. So early in the season, foundation should always be placed on the edge of the brood nest, so that in order for the brood nest to expand, they actually have to draw that comb. Later in the season, you can be much more bold, and when the brood area is absolutely crammed with bees, you can actually take out the combs you want to remove and interleave them with frames of foundation. And the one place never to put a frame of foundation is next to the hive wall. So the use of foundation has a dual purpose: preemptive swarm control and brood frame renewal. And one of the beekeepers tend to be a bit tight-fisted over money, spending it on foundation, but in actual fact, you get a bonus because the queen will always lay more eggs in new comb. Questions: what do you do with the removed combs? Well, poor combs taken out of circulation, we melt them down and recover the wax. In fact, each year over the last 5 years, we've recovered enough wax each year to completely supply us with foundation. We have an exchange system with the foundation makers that they will give us so many frames of foundation for so many pounds of honey, and no money changes hands, and we have not paid for foundation for about 5 years. Good frames containing food can be put aside for use elsewhere. You don't want them in the brood nest because they're not capable of, once they've got sealed honey or are filled with pollen stores, they're no good in the brood area. They want to be elsewhere, and we often put them aside and they're used to feed frames or for nukes, or we sometimes use a system called a dump box. We will actually have a box on top of a hive, and we will dump any combs that we don't want in the brood nest there, and they can remain there for the rest of the season, or they can be put to some useful purpose. But this is not a thing to do if you have a disease problem, because it is an ideal way of spreading disease from one colony to another, moving frames about. We are very fortunate where we are, that on the Isle of Anglesey, we have not had American foul brood for 45 years. And we had only one case of European foul brood, and that was in colonies that had just been brought in from England. And so we don't have to be careful, particularly about the moving frames about within our own hives. What we do quite a lot is, if frames have got a small amount of brood in them, but the rest of them isn't really available for the queen, we will put them in a dump box for the brood to hatch out, or we'll do what we call a partial Demaree, and we'll come to the Demaree method of swarm control in section 3 here. I've spoken to this. If the only thing about a dump box, if you put any, if any of them are worker eggs or young larvae present, you need to have a quick check for queen cells after 5 to 7 days, because the bees there they're not really in connection with the brood nest at the bottom of the hive. They may be far enough away to think they're queenless and start emergency queen cells. We also have a system by which we move boxes, and we work on a 2-box system, which is called a brood and a half. Our queens are just nicely able to lay in a shallow box and a deep box, and we call this system a brood and a half. It's a people either love this system or hate it. We actually love it. It suits very well with our method of management. But a two box system does make it much easier to do some of these things. And I say this swapping the boxes round is only possible if you have a 2-box brood nest. And the target always of box management is to ensure that you have brood in contact with the queen excluder over as much of its area as possible. And the aim is to avoid a honey ceiling in the upper brood box, because once there's a ceiling of sealed honey, the bees will not break through this to allow the queen to extend upwards. If you have double brood boxes, and we sometimes have colonies that do this, you can just move. You don't have to move the boxes. You can just move the frames. So what we do, and this is in completely different from what it says in the books. And I was checking up on this yesterday. I was actually looking in the your American book, the ABC XYZ of Beekeeping, and we actually move we move brood up into the upper box and empty frames into the lower box. And what it says in all the books is that the space for the queen to lay should be put above the brood nest, and we find this is totally incorrect. That the bees, when you provide area above an established brood nest, the bees immediately regard that as being a place to store honey, because they want to have a store of honey close at hand, and this is their natural behavior. And if you actually look at what a honeybee nest does in a tree cavity, which is usually fairly tall and narrow, during the winter they will have eaten their way fairly well up this cavity, and the brood nest will start fairly high up in this cavity, and then it will gradually extend downwards. And this is their natural behavior. I can't understand why this advice is given, because it just does not work. We quite often will put boxes that have got a lot of stores in them under the brood nest. And believe me, the bees regard this as being the totally wrong place for stores to be. They will remove this. It can help if you run an uncapping fork over it to take the caps off, but we don't normally do that. The next day when they have poor weather and they're not busy foraging, they will completely strip this out, and then the queen becomes able to lay down into it. But honey supers are always said to be very important, that you have lots of space. And you need to add supers when a flow is expected, or when the previous supers are full of bees, not full of honey. The time to add a super is when the top super is more or less wall-to-wall bees, even though it may not have much honey in it. Because you must remember that the incoming nectar probably has 3 or 4 times the volume that it will eventually become when it's been dried. So bees need extra space in which to do this processing. One of the things that is very well established is that if a colony has a surplus of drawn combs on it, this actually stimulates foraging. The bees will forage harder with the knowledge that they've got a lot of drawn comb available to them. Because we live in a fairly cool climate, we have to be careful about this, because if we add too much comb early in the season, too many supers early in the season, then we can give the colony a we can cool the colony off, give it a thermoregulation problem. A box is a foundation, in the supers boxes of foundation should be added fairly low down, either on top of a queen excluder or on the next position up. And as I said, the volume of nectar is important. Does super management influence swarming? It's often said it is. I'm not sure on this question. Generous supering is certainly not a substitute for poor management below the queen excluder. And drawing wax in supers is supposed to inhibit swarming. I'm not quite sure that it's such a powerful mechanism of drawing in the brood area. It certainly gives plenty of space for the bees to hang out in, but when we get this cooler weather during depressions, they will all go down into the brood area to keep warm. And this is what is the stimulus for starting queen cells. So extra super is encouraging foraging, but if you put too many on, you can result in part-filled boxes and frames. Method 3 now, this is brood location. As I say, this is the oldest trick in the book, and it's called the Demaree method, and Mr. Demaree published this method in 1892. And it consists of removing frames of brood from the bottom of the hive and relocating them in a box at the top of the hive above the supers. And the purpose of this is a dual purpose of this. First of all, it attracts nurse bees from the main brood nest to go up there and tend for this brood. And it's amazing how quickly the nurse bees relocate themselves. And also it reduces congestion at the bottom of the hive and gives, because in the bottom of the hive you give new frames, preferably drawn ones if you've got them, but sometimes it just has to be foundation. And this gives a huge bonus of space in which the queen can lay. And the result of this is that no brood is actually removed for the colonies. So the size of the colony is not affected. It may have a short-term effect on colony growth, because the migration of a lot of nurse bees to the top of the hive may mean that the queen does not have quite so many to service her, but that is soon rectified. Demaree does not have a separate entrance to the top of the hive. The bees do not fly from the top of the hive. They have to, in a proper Demaree, they have to come down through the supers and go out, come in and go out through the normal entrance of the hive. If you put a split board on it, it becomes something else other than a Demaree. So there are variations of this method, but the basic principle is the removal of brood from the bottom of the hive. In a full version, the frames that are put to the top of the hive, when the brood has emerged, you could move them back to the bottom of the hive to do a sort of a cycling system. But what we find, and I think most beekeepers find, is that as the brood emerges from these frames, they attract a lot of nectar and quickly become unavailable for brood. This was originally designed for hives, very prolific colonies on double or even triple brood boxes. So here's an example, one that we might do. here we have a colony with a double brood box, and we've taken a lot of brood up to the top of the hive here, and this has attracted nurse bees up to here, and the queen is down here now. She's had she's just got 4 frames of brood and another 8 frames in which she can lay. And we also do it sometimes. If you're on some of our beekeepers just keep bees on a single brood box, in which case you do something like this. You put, and it's absolutely full of brood now, so you put 8 of those to the top of the hive in a new box and leave the queen at the bottom on just 4 frames of brood and plenty of space to lay. You can adjust this as you want, and we do partial Demarees where we only want to move a few frames up, and we will just put a dummy board either side of this to keep the nest in shape. With a Demaree, you do have to check if you're putting brood up. They may decide they're queenless, and you need to check for production of emergency queen cells and destroy them before you get an emerged queen at the top of the colony who won't get out to mate, but young queens can sometimes squeeze through queen excluders, and I have no idea what would happen if you have a virgin queen doing that, whether she would kill the old queen or what would happen. We've never had it happen, so I don't know what the implications are, but I'm sure they're not good. As I said, they tend to fill the Demaree box with honey, and at the end of the season you have to extract honey from it. Some people don't, we don't particularly like extracting honey from brood frames, but as long as your brood frames are fairly young and are not black and have been used over many years, I don't think it affects the honey quality. And the final method of preemptive swarm control is splitting the colony. And all the previous methods have kept the colony in one piece. But splitting is different now, and now you are actually, now you're actually creating 2 potential colonies from one. But this is by far the most powerful method and reliable method of preemptive swarm control. And it serves the dual purpose of swarm control and making an increase or raising a new queen. In the UK, it's a well-established practice splitting colonies for beekeepers who live in the north of the country and get their main honey crop off heather. And what they will do, that in May, they will take a nuke out of a colony, which is a sort of, a minor split, and allow this to make itself a new queen. And then when they take the hives up to the heather, which is usually sometime in mid to late July, they will combine this nuke with the main colony to produce a super colony to take up to the heather. Splitting colonies is what Snellgrove uses his board for. It's one of many designs of split board, and a very fancy one. This is how we came into using split boards. People say that splitting a colony is the enemy of a good honey crop. It's often said just making a nuke will cost the colony a super honey. So, a major split of the colony might be worse. But splitting is always better than just leaving the hives to swarm. And it really depends when the splitting is done. If it's done at the right time, directly after the spring flow, which I've said is late May for us, you can actually get an enhanced yield. The two colonies will produce, the old colony and the new colony you have made will actually have a bigger yield of honey than if you had managed to keep the original colony together during this period. So we did 1 year, this is rather an exception that beekeepers sort of boast about. We had a colony and we actually, it was a very early season, we split it twice and we made 7 nukes from it. And these nukes were all furnished with bees from this colony as well. They had bees and brood from this colony. And at the end of the season, it had 110 pounds of honey and had accumulated enough honey that it did not need any supplementary feeding for the winter. Right, here's one I did earlier. This is a colony that, that has been split in this way. And here's a deep brood box, right? And then it has it has 1, 2, 3, 4 supers. Here is the split board, which has a couple of entrances open on it to allow free access of bees, a second brood box, and this contains the new queen and then 4 more supers on it. This really is a bit of a bit difficult to deal with. In fact, my wife and I usually beekeep together, but she actually had to be somewhere else at the time it came to harvest this honey, and I had to harvest this honey myself using a step ladder on rather soft ground. And there's a barbed wire fence just here. I very nearly finished being impaled on that. So I decided I wouldn't try this sort of thing again without engaging some help to do it. And that colony, actually, the bottom part of it, it was slightly over supered. The bottom part of that colony produced 75 pounds of honey, and the top half produced 65. So when you split a colony for swarm control, you have to judge how to split it. You want to do enough to prevent it from swarming during the rest of the season. But you mustn't overdo it, otherwise one of the sides of the split will be compromised. So you need to ensure that both sides of the split are viable, particularly in terms of the number of bees, because one thing you have to remember, when you split a colony, all the bees that have flown before will fly back to the position of the original colony. And it depends on recent activity how many bees these will be. If you split a colony just after there's been a major honey flow, the proportion of flying bees can be very high, and the part of the split that moves to a new position can actually hemorrhage bees to the extent where it isn't able to keep its brood warm. And you have to bear this in mind and be extra generous when you make the split if these conditions prevail. Right. I mean, one part of the split has the old queen, the other has to raise a new one, and the queen right part normally remains on the old hive site to gather in the flying bees, and the queenless part goes to a new location, which is either on a new stand or using a split board on top of the queen right part. We generally use split boards for this sort of operation. We don't have don't have an enormous amount of room in most of our apiaries, so we have to keep the number of hive stands down to something sensible. The queen-like part's the main honey producer, and the queen needs enough nurse bees to produce follow-up brood and to lay flat out to lay the new combs. It's a thing that requires judgment. And the queenless part will make a new queen, and this is important. You must have enough resources in terms of brood and nurse bees and food to do this properly. And under the right conditions, they will produce a perfectly new queen. That the business about emergency queens being inferior to swarm queens is largely a myth. If the bees have got a reasonable number of nurse bees and enough food, they will always make a good queen. It's one of these beekeeping myths. Oh, here are some splits. I won't go into these in detail. They're the sort of splits we will often make. And here we've just made up a new brood box which contains a substantial amount of the brood in here. I mean, this had 10 frames of brood, and 7 of them are now in here, and 3 of them in here. And then we've kept some food with this because it's a smaller colony, so we've got a couple of good frames of honey here. And this one has got a lot of new frames that the queen can lay. So she will carry on laying, and this will have a delay before it gets a new queen. So splitting is highly flexible, and when you're familiar with the process, it can be designed. You can design each split to meet the situation. And splitting does make increase that you may or may not want. But before a honey flow, you can always recombine the colonies to make a super colony. And this is where a split board comes in useful, because it's dead easy to reunite a colony on a split board. It's really just because split boards normally have a mesh panel on them. There's a common hive smell, and if you put them together, they will merge without fighting. So you can't win them all. Even the best preemptive swarm control, and that includes splitting, does not work 100% of the time, but it will always delay the swarming impulse. But colonies can retain the impulse up to the end of the swarming season, late June or July, and they may start to produce queen cells just at the time when our main nectar flow is starting, and this could hardly be worth timing. And that's both for you as the honey guy, for them, because there isn't enough left of the season for a swarm to get established. We've worked on this for a number of years, and we now have a technique which is in the booklets by which we deal with this situation. So this is the last slide in this preemptive swarm control. This is a clear indication that preemptive swarm control has failed, and we need to move on to reactive. And that's the ultimate proof that it's failed and we're too late. So that is half time, well, I hope. And if anybody's got any questions now, what I'll do is I will take the screen away, I hope, without ruining everything.
Hi, I have a question. I was wondering if you might describe a split board in a little bit more detail.
Have I got there's a diagram in the second half of one. There are lots of split boards. We use Snellgrove boards because one of the things that in the development of our swarm control method, As Snellgrove wrote his book right back in 1934, and he designed this all-seeing, all-dancing Snellgrove board that he used in a very specific way to regulate how many bees were in half of the split. Most of this is actually totally unnecessary. His methods are, as read in his book, seem very detailed and complicated and require a lot of intervention from the beekeeper. And this was because he designed his methods of swarm control based on the Gerstung theory of swarming. And this was a theory that dominated for about 60 years. And this theory said that what initiated swarming was when the colony got to a state where the queen was starting to back off her laying, and there were more nurse bees than there was brood to feed, and the excess of brood food was what was then started the queen cells. And this was the theory of swarming on which he based his method. It was subsequently proved to be entirely wrong. Some very elegant experiments were done on this by a gentleman called John Simpson, and it proved conclusively that this was incorrect. But a lot of his elaborate instructions for swarm control are totally unnecessary. You don't need all these doors. In our association, Apiary, we just use what we call a cover board, what you call a top board, I think. We just use a top board with a single entrance cut in it. That's all it's required for swarm control. We occasionally, for other reasons, use the multiple doors on a Snellgrove board. You'll see these later. There are in our board there are four sets of boards, 4 leading into the top of the board and 4 leading to the underside of the board. And by manipulating these doors, you can actually siphon bees. It's always nearly down the colony. You want to siphon bees from the top half into the bottom half. You could, in theory, go the other way if you wanted to. But just a very simple board with an entrance on it is all you need.
I have a question. During the spring and the summer, when you're looking to see if there's swarming issues going on, how often are you going into the hives to inspect them for this?
Well, during May and June, we will want to go to an apiary on roughly a 7-day cycle. But that doesn't mean that we need to look at every colony. We know that some colonies will have been split, and we can be tolerably certain they won't have queen cells in them, so that we don't need to look at them. So we use our judgment to decide which colonies are likely to have queen cells, and ones that we're confident won't have queen cells, we don't necessarily look at. But as I say, once the basic comb management has been done, then we will look for queen cells by just taking off the supers and just upturning the second of the brood boxes and seeing if there are any queen cells on the bottom bars. And then if we see any sign of queen cells there, then the colony will be subject to a complete frame inspection, and what we find will determine what we do next. But yes, it does require you to visit the hive, and people claim that opening hives all the time is a bad thing. I just don't agree with this. If you've got if your hives are properly made with the correct bead space, and your combs are properly spaced, you can look through a colony very quickly with very little disruption to the colony, and a few minutes after you've left, it'll be business as usual in the colony. We don't believe that looking colonies either impacts on their welfare or on the crop of honey they're likely to produce.
Thank you.
So Wally, if you do an inspection and you find there's a whole bunch of capped queen cells,
Yeah.
what's your next step?
The first step, well, first of all, you must ensure they actually are swarm cells. And you said a whole lot, so they almost certainly are swarm cells. But it happens to every beekeeper from time to time. They could be emergency queen cells, we've done it. We've accidentally killed the queen, and when you go in next time, there'll be a whole bunch of cells, and they will be emergency queen cells, and you can.
Well, let's assume they're not emergency cells. Let's assume they're swarm cells.
Hmm?
Let's assume they're swarm cells, not emergency.
Yeah, okay.
cells.
Well, if you've got capped queen cells, what is the most important thing to know now? And the most important thing to know, has the thing swarmed? Have you still got a queen there?
Wally, isn't this kind of the second half of your show? Though?
Yes, it is. Yes. You're asking me. That is the first thing to do. And I'm only really going to deal tonight with what you do with colonies that have swarm cells and have not yet swarmed. Right. The booklets contain instructions for what to do if the colony has already swarmed. But the most vital thing is to check whether it has swarmed or not. The original reasons I started to write this, because we have a bee inspection service in Britain where this is how we have this very good control over brood diseases. And these guys are all beekeepers themselves, and they have the name inspector, but in fact they are the beekeepers' friends. And the guy who's in charge of the inspection service in Wales said to me, we have our inspectors going around, and it's a very common thing that they get to open a colony and they say, Mr. Jones, your colony doesn't appear to have a queen. Do you know what happened? And Mr. Jones would rack his head and say, oh, well, a couple of months ago, I did see some queen cells in here, but I just destroyed them. And of course, what he'd done was to destroy queen cells when the old queen the prime swarm had already departed, and it was 4 or 5 days after this, and there was no longer any brood from which they could make an emergency queen. So the original booklet that I wrote with Queen Cells in My Hive was to try and prevent this happening. But I mean, it still happens. People still do this. They see queen cells in a hive and think, oh, we can't have those, I'll destroy them. And without any consideration to what situation the colony is in. So that's what you have to do, and based on that is what you do next. Right. If there are no more questions, then I would like to ask you a question. What do you guys do with a colony when you find swarm cells in them? How do you manage that colony? Do you have a method of artificial swarming for them? In the UK, we do. It's in all the books, and we are what you are told to do is to do an artificial swarm by what's called the pag den method. And I'll show you what that is in a minute in diagram form. But do you have a sort of standard method of dealing with this situation, and what is it?
Oh, you want to turn off?
Anybody going to volunteer?
Yeah. Well,
Okay.
it all depends on how much equipment you brought with you.
Well, the one thing you have to do, if you've got out apiaries, and we do, you have to try and have everything you might need with you, because sometimes time is of the essence. You really ought to do whatever you're going to do that day. So we go out in the summer. We've been doing a few years, so we know roughly how much equipment we're likely to need. So it's very rare that we go out without enough equipment if we're going around several apiaries, we sometimes have to go back home to restock. But we've got our apiaries in a fairly compact area in the southwest of the island of Anglesey, so we don't have very far to go to get any further equipment. Yeah, but you have to have it with you. Yes.
Yeah. So I generally just go for the artificial swarm, right? Find the queen, put her in a box with maybe a frame of brood, and take the rest of it away and put that queen and a frame of brood and other things back in the original locations, so she gets all the foragers.
So you take the queen away, and what, into a nucleus box or what?
No, I put her in a full length Stroth box, and that's what I leave in the original location.
So what do you do? So you've taken her and some frames of brood away. What do you do with the queen cells that remain?
Well, then I kind of make a decision as to how many nukes I might make out of that. It's either one or two.
You leave one or two queen. You destroy all but one or two queen cells, would you?
Oh, I generally don't destroy them all. I generally don't destroy any. I try and split them as much as possible. So.
All right. Okay. You're making multiple splits. Yes. I mean,
making multiple splits, but making sure they're generous. Leaving.
But
3.
a lot of beekeepers don't want to do this. So what do you do if you just want to keep that colony from swarming? Because you've taken the queen away, and you're in exactly the same situation now as though she'd been a clipped queen, and they'd abandoned swarming. The first virgin that emerges, they will swarm with.
Right. I always consider that it's like the fuse is lit. If there's queen cells, you can't turn back now.
Right. Okay. So you've retained your old. One of the popular methods in Britain is to take the queen out and put her in a nucleus box to kick her heels, and then they will go into the colony and destroy all but one of the queen cells, and that has to be done, of course, after there are no longer any brood at a suitable age for them to make extra cells, and they will choose what they regard to be the best looking queen cell and leave that behind, and then the colony cannot swarm. And it's a satisfactory method, except that you are deciding who the new queen shall be, and it is part of our apicentric beekeeping. Bees always make multiple queens. Why? Because presumably because they want to have a choice, and all the work with observation hives shows that there's a great deal of elaborate behavior goes on in a hive that's got queen cells. When they reach the about 3-4 days from maturity, these queen cells start to be intensively investigated by the bees, who again do this vibration dance on the queen cells. They shake the queen cells, and presumably they are looking for some response from the occupant, and because the queen cell is permeable, they can also assess the bouquet of queen pheromones that this queen is producing. And the people who studied this, they can see which queens aren't going to make it. They can't always decide exactly which one will be chosen in the end. And there's a mixture of the workers themselves destroying some queen cells, and queens being allowed to emerge and fight each other, kill each other. But a lot of this fighting, I think, is a fixed contest. The bees will hold down one queen while the queen they want to succeed dispatches the one they don't want. It's a complex business, and it's evolved over millions of years, this method and I prefer to try and let it run its natural course and let them decide from a reasonable choice of queens which one they will take on to the future. I don't want to play the role of God in all this.
Hey Wally, I have a question about so there's usually like 5 different genes there in a hive, right? Presumably there's not just the, you know, because she's mating with different drones. Mm-hmm. Is it possible that one subset of the colony fights for the right for their gene, their queen, to go first?
You're talking about nepotism now.
A little bit.
Yeah, well, it's a very, very interesting subject. Basically, it's not known. I've dealt with this at some length in the book, by the way, because this is all part of the biology. When a colony cannot afford to be nepotistic because it would destroy cohesion in their workings. The fact that they have different fathers and there are all these different families or sisterships or patrilines, they're called, in the colony, they are in theory in competition with each other. And the fact that they work harmoniously is down to the fact the colony has ways of dealing with this. And these ways are extremely effective in that they do not disrupt the colony in any way that is significant. For example, when it comes to feeding larvae, there's a very slight preference for a nurse bee to feed one of her sisters than another larva that isn't her sister. They can actually tell the difference from the chemicals there. It's only very slight, and it doesn't actually affect anything. All the larvae get fed, but there is a slight preference. Where where nepotism really becomes evident, according to me, now this is during second after swarms. When a colony is left to swarm, it will usually produces a prime swarm, and then about 10 days later, it will produce a first after swarm. And this first after swarm will normally contain one queen. But if this is allowed to run, the next swarm to emerge, the second after swarm, will often contain multiple queens. And it's in the literature, actually, there have been after swarms with 14 queens in them observed. And we have studied these after swarms with some interest. and they often contain multiple queens, and because they aren't queens that are highly valued by the bees, you often see them just wandering about in the swarm. You'll see one pop up on the surface of the swarm and disappear again, and another one will pop up. Now, what these multiple queen swarms often do is to subsequently split themselves. They can split themselves at the point of swarming. They can settle down in a cluster, and then those two clusters will separate, and one lot will go off on its own. You can shape these swarms into a hive, and they will occupy different parts of the hive, and eventually one will have to leave to allow the other one to develop, or they can do a whole range of things. But these are all based, presumably, and we can't tell positively because the work's just not been done. These are based on the fact that they all prefer one queen as opposed to another one, and they're prepared to go to great lengths to exercise this choice, even though with these much smaller swarms, they are probably destroying any hope of them surviving, because the swarms, each time they split themselves, the swarm is getting smaller. So this seems to be non-adaptive behavior, that they are actually, by showing this affinity for a particular queen who is presumably more closely related to them than the other queens, they're actually destroying their own hope of being successful. But what I've argued in the book is that caste swarms have a very low probability of success anyway, even the first one. So caste swarming must be adaptive in some way to the colony, and I can't really go. This is argued. It's quite a long chapter on caste swarms in the book about what happens in caste swarming and how it can be adaptive for the colony to caste swarm, rather than trying to keep all the bees in one place. But it's a complex argument, and it's, if you like, there's very little investigation of caste swarms have been done. I actually asked Tom Seeley about what he knew about caste swarms. He said, well, I've never really thought about them. So there you are, you see. The man himself has never even really thought about them. However, if you read the book, there is what I hope is a coherent, if not necessarily correct, account of this.
For many of us, caste swarm is an unfamiliar term. I presume that means any swarm after.
Yeah, that means after swarm. Yes, sorry. Yeah, we use the word caste. Sorry, I do know you call them differently than us. We call top boards cover boards, you see, and all sorts of things like this. Yeah. Do you want me to go on the second half now? Yes?
Yeah, sounds like a good idea.
Okay, I'm going to deal with reactive swarm control in the second half. And you haven't really given me a proper answer about what methods of artificial swarming you use, and I'm presuming that it's not very widespread in your beekeeping practices. So it's quite a long section, and I'm going to cut it fairly short and just explain to you the main elements of it and why we don't use the method that is recommended to us in what is called the accepted method of artificial swarming. And the accepted method of artificial swarming in the UK is this method called the Pagden method. And it's a very peculiar story, because it has this, it's supposed to have been invented by a gentleman called James Pagden, who wrote a leaflet about it, and I've not seen a copy of this. I mean, it's a rare document, but apparently it was nothing about artificial swarming. In fact, Mr. Pagden never used a modular frame hive, so he could never have actually looked at his colony and known whether it had queen cells or not. Therefore, he could not possibly have invented this method. So how he acquired the credit for inventing it, I have no idea, and probably we will never know. It's just one of these mysteries. Right, now, if I can get this correct, I'll go on to the next part. Hold on. Ah, there we are. Okay, I know how to do it now. Okay. So, right, okay. Do you have a recommendation? This is the question I've asked. And the UK has the Pagden method. I mean, it's standard in all beekeeping books, who just tell you the how to do it. You are led to assume that you just do it and then everybody lives happily ever afterwards. The colony doesn't swarm, and this is what we had terrible trouble with when we first started to beekeep. We could not make this method work. It worked sometimes and not others, and we could never come to any rhyme or reason why it didn't work. And we now pretty certain we know why it doesn't work reliably, and I will come to this when I describe the method, right? So reactive swarm control, where it's when preemptive swarm control ends and when queen cells with contents are found. And the swarming process cannot be reliably turned off. Occasionally, very, very occasionally, it does turn itself off, but this is not really of practical importance because it's not reliable. Destroying queen cells, you can destroy queen cells, but it only delays the swarming process, and it may actually make the problem worse. So it's best the beekeeper accepts the inevitable, because you do anything wrong now and you may lose the colony. So the thing I'm going to deal with now in this talk is just when queen cells are present and the colony has not issued a prime swarm. Now, the solution to this is artificial swarming. And this is usually just taught as a recipe, but we have found it very helpful in the development of the methods we use to try and understand better the beekeeper's interaction with the colony. It helps to know how swarming works. It is not fully understood, and I have, in the book, have produced what I call a working hypothesis. In other words, it's an explanation of how it works. And this is a useful explanation until somebody disproves it or you find exceptions. And this was the aim of the book. This is why I actually wrote the book in addition to. So yeah, I've produced a working hypothesis, and so it's up to be shot at. This is what the beekeeper is up against, right? Okay, the working hypothesis is that the swarming process is organized by what we call the swarm organizer bees. These are a group of bees in the colony who actually run the process. And these bees may actually start right at the beginning. They may initiate this change behavior towards the queen, right, when she starts to be subject to the vibration signal and all that stuff. We cannot identify these bees at any point in the process of swarming except at the time when the swarm actually issues from the colony. And these are the bees that actually initiate the swarm. They conduct the warm-up period, which lasts about an hour when the bees are being activated so their flying muscles are all warmed up and ready to go. And so at this point, you have to realize that these bees, these swarm organizer bees, have to have two different separate sets of knowledge to know that it is the right time to swarm. They have to know the maturity of the queen cells in the hive, and they also have to know what the weather is outside. Is it suitable weather to do this? So it's inevitable, since they must have feet in both camps, so to speak, both inside and outside the hive. They must be inevitably flying bees that are able to go out and see what the weather is, and probably also have some sort of knowledge of the terrain. These bees are just a small minority of the flying bees, and there's no way that we as beekeepers can distinguish them from dedicated foragers except when they are fulfilling their role of controlling the swarming process. And what we don't know is, are these the same bees throughout the whole process? Because if you think about it, go right back to this change behavior of the queen. In order to initiate this behavior, these bees have to know a lot about the economy of the hive. They have to know that they've got enough brood and bees and stores for it to be the time to start up the process of swarming. And it basically, we have no ideas what these bees are. There are some bees in a colony. The prime suspects are bees called messenger bees, right? And there are bees in a colony whose specialized role is to locate the queen, collect queen substance off her body, and then move out into the hive and make numerous contacts with other bees in the colony, passing on small amounts of this queen substance. They are probably the prime suspects to actually be the actual initiators. But whether these are the same bees right the way through to the point of swarming is just not known. Bees have a funny way of doing things. I mean, I think anybody who's read Tom Seeley's Honeybee Democracy and read about the details about how the scout bees locate a suitable nest site, and the fact that the scout bees actually change during this process in order to get an independent view. The original scouts go into retirement and new ones take over to check that they got it right. And this is a fairly common thing amongst the bees, that bees have these specialized roles, but the bees that are doing them can change with time. So we basically don't know, but what is important in swarm control is these are flying bees. And because they're flying bees, we are capable of manipulating them because they're flying, and therefore they know the hive location, so that when you do an artificial swarm, what we call the parent colony, that's the part with the queen cells, goes to a new location. Any method, always the same. Goes to a new location. It may be on a new hive stand. It may be on a split board, but the parent colony goes to a new location, whereas the artificial swarm that the beekeeper is going to create stays where it is. So the flying bees automatically finish up with all dedicated foragers in the artificial swarm, which is in the same hive position. So that is how, this is the important part of the manipulation in artificial swarming, to get these swarm organizer bees away from the queen cells. Okay. So initiation swarm, regardless of whether they join the swarm, all the workers engorge with honey, right? And this amounts to about 30 milligrams. So it's not as much as often people say, oh, the swarm has flown away with all my honey. They can't actually carry that much. The workers become very active to warm up for flight. Swarm initiator make buzz rodents across the combs. They also make squeaking noises. The queen is chased or molested by the workers. And finally, the swarm emerges from the entrance in a continuous stream. I'm sure we've all seen it. But the basis of all methods of artificial swarming is to separate the flying bees from the queen cells. As I said, the artificial swarm stays put where it is originally located. The remainder of the colony, which contains most of the brood, the queen cells, that I will call throughout the parent colony, right? So this is the artificial swarm and the parent colony are two separate things. And the question is, where does the queen go? Does the queen go to the artificial swarm, or does she remain in the parent colony? The flying bees automatically contain the swarm initiators, and they always finish up in the artificial swarm. And what determines the outcome now is the information that is available to the artificial swarm that determines the outcome of your being a successful or unsuccessful artificial swarm. And this is where we return to this bit about the composition of a swarm. We've already said, I won't go through it again, we've already said that the artificial swarm is rich in young bees. As I've said, 2021 is the 81st anniversary of the research that made this discovery. And the swarm has a totally different age composition. A natural swarm has a totally different age composition from any artificial swarm that we are capable of making through our manipulations. So the beekeeper is totally unable to replicate a true swarm in terms of the age of the bees. So this is where the booklet deals with now. This is what deals with all this side of it now, about what you do when you get into artificial swarm. So what I'm going to deal with now is just those colonies that have set up queen cells that are not yet swarmed, and then the solution to this is artificial swarming. In the booklet, that booklet I just showed the picture of, it also tells you what to do with colonies that have already issued the Hive swarm. But as far as you can tell, there are none of the queen cells left behind have yet emerged, so there's not a virgin queen in the colony. And the next stage you have to deal with is that when you go in and you find that some of the queen cells have emerged, and that the colony may or may not have issued a cast swarm, it may or may not have a virgin queen wandering about in it. And then there's some last-ditch post-swarming management that deals with all sorts of situations when you don't know whether the colony is going to requeen itself, right the way through to the fact that you can be pretty sure it hasn't requeened itself, and also when it has requeened itself with a drone laying queen. Those are all dealt with in the booklet about what to look for. So it's a series of 12 steps where you are told what to look for, and if you find these conditions pertain, then this is the best way of management to get a positive result. So basically, if your colony has progressed past stage 1, you've taken your eye off the ball. You haven't looked often enough to get there before it has issued a prime swarm. So the first question you have to ask, and this came up in the questions at halftime interval, first of all, you have to say, you've seen queen cells, but are they swarm cells? And we did make a mistake this latest season. We looked in a colony and found some queen cells, didn't ask any questions, artificially swarmed it, and it actually was a superseder. It all ended happily in the end, the colony requeened, but we made a mistake. So 9 times out of 10, when you see multiple queen cells, it will be swarming, but I already said it could be, sorry. Okay, you just have to check it's not emergency queen cells, and I say the age, the youngest brood will tell you when these cells were started, because they were started within hours of them losing the queen, and there'll be no laying after that period. So swarming and supersedure can be bit ambiguous, and we do suggest in the booklet it has a sort of a belt and braces type of solution. If you're not sure, you do the following, and then everything should recover. So there we are. I think we can say this is quite unambiguous. This is a colony that's hell-bent on swarming. We've become very interested in the variation in the number of queen cells. In recent years, we have found that there may be 10 or less queen cells. And in the past, I have seen 100 queen cells in a hive. And is this a characteristic of the colony? And I think there's some truth in this. It also varies from season to season. But one of the main reasons I think the number of queen cells varies is the extent to which you have done preemptive swarm control. What you have to realize that preemptive swarm control is all aimed at persuading the colony that it is not ready to swarm. So in fact, you are actually destroying or masking the information that allows the bees to make this crucial decision: is now the time to swarm. And I think this was what this results in, that it's not quite such a clear-cut decision as it might have been if you hadn't done your management. And this is what results in the reduction of the number of queen cells. That's speculation, by the way. So it's definitely too late to make an artificial swarm, but this is the point where you have to, well, A, gather the swarm, and B, find out where the hell it came from. So the first priority is to determine what stage swarming has been reached. And as I said, the booklet is a diagnostic tree with 12 steps. So you need to inspect the colony to find out what stage it is in before you decide on what management is appropriate. And for the first 3 weeks after swarming, there is evidence on the combs. You just need to know how to read it. So you do absolutely nothing until you know what is going on, what stage you've reached, because only then can you decide what is an appropriate method of reactive swarm control. So the colony is not yet swarmed. How do you know? Well, here's the evidence in order of reliability. You can see the queen. There are recently laid eggs. That is, eggs that are in the bottom of the cell and standing on their end. Because I don't know whether you've noticed this, but in the second day, an egg starts to lean over at about 45 degrees. And on the third day, just before it's about to hatch, it is lying flat in the bottom of the cell. So you can actually tell clearly that if you see queen cells on their end, they're still standing upright, there has been a queen there within the last 24 hours. If you know your colonies well, the first sign the colony is swarmed is you go to take off the supers and you find there's a lot of bees that were there last time that are no longer there. In other words, the bees have lost, and then you can be absolutely certain that when you go in there, the prime swarm will already gone and the queen is no longer there. And the maturity of the queen cells, not a reliable guide, because some colonies can swarm well before before they are capped, and also swarming can be delayed for days on end because the weather hasn't been suitable to swarm. So we did actually go to help another beekeeper who the previous day had a swarm issue from his hive, and when we went in there, the queen cells, the other queen cells were beginning to, queens were emerging from them. So they'd run right up to the time limit before new virgin queens started to emerge. So that can be very variable. So, okay, you're now confident that the colony hasn't swarmed. So the only option is do an artificial swarm. And this is urgent. This is why you need to have the equipment to hand to do an artificial swarm. So you can look at the maturity of the queen cells, and if they're all unsealed, you've perhaps got time on your side. They may be a mixture of sealed and unsealed, in which you're running a risk now, or they're all sealed. If all the queen cells are sealed, and if the queen is still there, then you've been lucky. And you also have to take into account the time of day and the weather conditions. If it's a really nice warm day and you've got up earlier and you're in the apiary looking at your colonies at 10 o'clock in the morning, then they could easily swarm that day. Conversely, if you're there in the late afternoon and you see stand-up eggs, that doesn't necessarily mean the queen didn't lay those in the morning before they swarmed in the middle of the day. So you have to be cautious about things. But it's urgent that you do something. If you don't do something there and then you are running a risk. So okay, this is the Pagden method, which I mentioned before. And this is what all our beekeeping books recommend. And this standard method separates the flying bees and the queen from the brood and queen cells. So this is the artificial swarm, flying bees and the queen, and the parent colony is all the brood and the queen cells. How does this method work? As I said, our books gloss on the outcome, but give the impression that no problem. It's assumed that it's working well. And we actually have one book which says it is virtually 100% reliable, and we found something quite different over the years in which we tried to do this method. I mean, first of all, it didn't work on the colony swarm. We thought we'd done something wrong, and then we wondered whether it was our bees that were the problem, whether they were just extra swarmy bees. But we gradually came to the understanding that it had nothing to do with us, just that the method didn't work. Right, so this is the Pagden method. This is what you do in the Pagden method, and this is shown here as being done with a separate hive stand. So here you've got your colony on the way we get brood and a half, which are a number of queen cells in it, and you get a new box which is color-coded blue, and you take one of these frames out, and it has to be a frame on which there is only sealed brood. There is nothing of an age from which they can make queen cells, and that is put in the middle. This is on the same hive stand, right? That is put in the middle of the box, and the rest of it is hopefully drawn combs if you've got them, but if not, it has to be foundation or a mixture of drawn and foundation. It depends what you've got available. And this is the artificial swarm over here. This is the parent colony over here. And that contains everything that was in this box, apart from the queen and apart from this one frame of sealed brood. And immediately all the flying bees fly back here. This totally loses its impulse to swarm because it's lost the bees that were organizing the process. So, and again, our books are available. Most of them say that you've got to thin these queen cells or this will swarm. Categorically, you do not. This colony will sort out the queen it wants from however many queen cells and make no attempt to swarm. So you just leave this one alone until it requeens itself. This is the problem one. Now, this is the one that can do one of two things. It can either continue with the impulse to swarm, and the queen will lay a bit, and they will immediately start queen cells, and then they will be off and away. Or it can, which is what the books claim it does, they can hunker down, accept the fact they're supposed to think this artificial swarm is supposed to think it has swarmed, and if it did that, it would just hunker down and rebuild itself, right? Which is what it's wanted it will do. But yeah, this is just what it says in the book. So I won't talk. I've just talked. So we tried this over many years, and it's now more than 50% sexual. And we had various theories that we were doing it wrong. We tried different small minor variations, but none of it made a scrap of difference. It still didn't work reliably. And when you talk to beekeepers who have tried this method, they're honest, and a lot of beekeepers aren't honest in their answers. They agree that the Pagden is a very unreliable method. Now, I've given lectures to all sorts of beekeeping associations, and when I give a talk on reactive swarm control, at the beginning I say, right, anybody who's used the Pagden method and has found it to be successful, will you please share your secret with us? And I must have given at least 20 talks like this, and one person stood up and said, "Yes, I found it reliable." So I said, "Okay." And then he said, "Oh well, this is only my second year of beekeeping. I've only got one hive, and I've done it once." So that produced quite a lot of laughter. That's the only person who's ever said. And several people have said, "Oh, thank God, somebody." somebody says it isn't reliable. I've been using it for years and I can't get the hang of it. So yeah, there we are. So we had a long voyage of discovery, which is explained in the book. We discovered Snellgrove's book and made some of his famous boards. And his board was originally just designed for preemptive splitting of colonies, but in a very specialized way. So his book is actually in its 16th reprinting, by the way. And a lot of beekeepers have a copy of it, but I have never yet met a beekeeper who had a comprehensive knowledge of what the book actually said, or have tried the methods described in it. Anyhow, we had a go at following what Snellgrove did, and he wanted to do preemptive splitting, but like all of us, he made mistakes and he misjudged colonies, and he'd come to them and he'd find they got swarm cells. So he used his board to do what in effect was a vertical Pagden method. And we followed suit. As he didn't say whether it was good or successful or not. We followed suit and used the board, but the use of the board had absolutely no effect on the outcome. The Pagden method using this board made no difference. Oh, for those who want to know, this is a homemade Snellgrove board, and there's another door underneath this as well, leads to the other side of the board, and it has this piece of mesh in the middle that maintains the hive smell and thing. And you can open and close these doors in a controlled fashion to divert bees up and down. It is, as say, for artificial swarming, it's not required. And this is bees at the entrance of one of these. There's one colony below, another on top. As I said, Snellgrove sounds horribly complicated, and most beekeepers have not got a grip on it at all. And he wrote very prescriptively. He gave exact timings which to do all the various things, and it just overwhelmed people. We had a go though, and quickly discovered that a lot of the complication was unnecessary, and in some cases was actually a dangerous thing to do. Some of his instructions about changing the doors on the board. And the board can be used very imaginatively. You can do it for all sorts of things, but as I've said, for the purposes of reactive swarm control, a simple split board with one entrance is all needed. And this is what we use. Now, this is just one of our top boards, and it's had a part of the rim cut away here to make an entrance. And the holes we use things called porter escapes, which are one-way valves for when we're taking honey. Those have just been covered in mesh, and this works perfectly well for reactive swarm control. Anyhow, we delved a bit more deeply into Snellgrove's book, which I say is not an easy task. And we discovered Snellgrove had a second method that he called Method 2. And he uses Latin numerals, by the way. He was a classic scholar. And we experimented with that. And it certainly gave better results. But we found it had an inherent problem in it. And we briefly stopped using it and returned again to try and make Pagden work. But this was just a short period. Snellgrove hit on, as lots of things are, he hit this method too fortuitously. Instead of getting the queen in the artificial swarm, he somehow got in the parent colony along with the queen cells and brood. And at his next inspection, he realized this mistake. He actually claims that the queens had got through his queen excluder. So either he got a very dodgy queen excluder or he's being slightly economical with the truth. And to his great surprise, that when the queen was with the queen cells and the brood, in the meantime, all the queen cells had been torn down and the queen had resumed laying. So what he did then is he returned the queen to the artificial swarm, which settled down and did not swarm. And he wasn't sure about all this. He did it again deliberately and discovered it always worked the same. That when the queen was put with the queen cells and the brood, the queen cells were torn down and the queen started to lay again. And this is because this colony no longer has the bees that are trying to run the swarm. They've all gone in the artificial swarm. So what happens is that this colony quickly realizes it's got queen cells and a queen, and it certainly doesn't want the queen cells. So the workers themselves actually tear down the cells, but they do not actually do this until about day 11, 12, when it becomes obvious that they have got queen cells with queens in their midst. Bees don't appear to be fully aware of queen cells that have yet not, until they've actually got a queen who is fast maturing in them. So that you have to wait a number, if the queen cells are unsealed when you do this split, then you have to wait until they're not torn down for several days. Of course, they're not really clear that they've got queens in them. And when they do realize they've got queens in them, they say, "Oh, we've already got a queen, we don't need these." They tear them down. And this, of course, the disability is when people are doing grafting, they will start the queen cells off in a colony that hasn't got a queen, and then they will mature them in a colony that has got a queen, and until they get nearly mature, the bees will just go on happily feeding the queen larvae, and you only have to protect them in the latter stages of the development, otherwise the bees will tear them down. So it's exactly the same thing as that. Yeah, he returned the queen to the artificial swarm on about day 10. And of course, the queen's been laying in the parent colony. So as soon as she is returned to the artificial swarm, they start to make queen cells out of her most recent laying, and they make emergency queen cells and requeen themselves without swarming. So the ideal method. Right, okay. This is it done vertically, and the only difference from the Pagden method that is here is that instead of being in here, the queen is in here, right? And the flying bees would never go back to the bottom here. And this again is what Pagden said to do. You put one frame of sealed brood in here, just to keep the bees, so the bees don't abscond. Right, so this is the difference. The queen's in the parent colony. One of the big advantages of this method, of course, you don't have to find the queen to do this initial first stage of the artificial swarm. And that is a great advantage, because one of the most difficult tasks is to find a queen in a colony that is fairly close to actually swarming. This is because she will not be doing her day job. She will be harassed by the workers, given the run around, and she could be anywhere in the brood area and probably moving fairly fast at the same time. So the fact that you put the queen with the queen cells sounds counterintuitive, and many beekeepers just refuse to believe this is possible. What the artificial swarm has no queen now and no means of making one. So 9 to 10 days later, you do the second manipulation. So this is the second manipulation now, and this is where the queen cells were, and they've all been torn down. The queen started to lay here, so you put her back in the artificial swarm here, and you do this in a nice way. You just find the frame with her on it. She's much easier to find now because there's a reduced number of bees. She's back to her day job, so she'll be found on a frame somewhere laying. So it's quite easy to find her usually, not always, I have to add. And then you return here just on the frame she's on, usually with the bees that are surrounding her at the time. And she seems to be, they've only been apart for a few days, so she's well accepted. Right. Now, the problem was the bees in the artificial swarm are really desperate because they have got no queen and they have got no means of making a new one. So they're really facing their demise. So they are very unsettled, and they wander around trying to find the queen. And sometimes they do find where the queen has gone. And what you see then is, because this has been done vertically, you see the flying bees coming in here, and you see a crocodile of bees walking up the side of the hive and going in here. And if this is allowed to persist for any length of time, enough bees will, the swarm initiator bees will find where the queen has gone, and they'll go up here, and that this will actually issue a swarm. It's quite easy to remedy. You just take the whole of this part. This is its split board, by the way, this blue thing. You take the whole of this away and put it somewhere else in the apiary. And that causes these bees to lose where the queen has gone, and then normal service is resumed. But it's a very awkward thing to have to do. And if it's in an out apiary, you're likely to miss the signs that this has happened. And so again, because of this, we abandoned the method for a bit. Okay. We also found that the method 2 actually was better than Pagden, but it still wasn't actually 100% reliable. So we had a eureka moment. I think a couple of years, next year or the year after, I can't remember. And we asked the question, what would happen if we gave this artificial swarm brood from which it could actually make an emergency queen cells? Would this prevent it from being bothered to look for the queen? And yes, it did. It solved the problem, and but we realized there was something much more fundamental about this process, and this discovery is the really key one. And this is something that this thing's called serendipity, finding something by accident. This is the change now. Now it's exactly the same as the previous slide, except we have put 2 frames in the artificial swarm that contain eggs and young larvae from which they can make queen cells. And that's the only difference. The queen is still up here with the brood and queen cells. This is the only difference. But the fact they've got these stops them from finding the queens up here. And the second manipulation, again, is just the same. You put the queen, 9 or 10 days later, you put the queen back again, and you take these, there will be emergency queen cells here, and you can take these away. Quite often we will use them to put in the parent colony to allow it to requeen earlier. If they're nice, big, fat queen cells, we will make use of them, but you have to take them away. And the queen is put back here. And if you think about the time in 10 days, these queen cells are getting near maturity. So these bees in here will be well aware of them. These queen cells I'm talking about, these are the emergency queen cells. The bees will be well aware that these contain queens. And the fact that they suddenly get a laying queen to return them does not, in exchange, does not faze them at all. They accept her fine and just carry on with life. And as I say, we sometimes use these queen cells instead of allowing them to make emergency queen cells up here to queen us apart. And this method is 100% successful. If we hadn't done the method vertically using a split board, we would probably have never found this out, because if you do the method horizontally, there's probably zero chance of the bees in the artificial form finding where the queen has gone. So it was the fact we did it vertically that we were able to discover this. And this is the fundamental difference. You have given the artificial swarm a different priority now. Its original priority, as contained in the swarm organizer bees, was the swarm. But now they have a second and prior and greater priority to get a new queen, and that's the one they run with, and they do not swarm. We know from experience there is a slight residual. These swarm initiator bees are still present in the colony, and they still contain an urge to swarm, but they are outnumbered by those that don't want to swarm. And I don't think that actually the urge to swarm ceases to exist until those bees die. And since they are already of fairly mature years, probably that doesn't take too long. But we know from other experiments we've done that there are other manipulations that we can do that show that they still exist there with an urge to swarm. So this is the same thing done on 2 hive stands. You don't have to use a split board. These are all in the booklets and in the book, by the way. I mean, you can't take all this stuff on board. You have to look at it in detail, and you probably need to have diagrams like this to hand in the apiary when you actually do this for the first time, and perhaps the second time too, until the process becomes familiar to you. And then it's the same 2 things. You return the queen after 10 days to the artificial swarm. As I said, the artificial swarm has now the means of making this prevents them looking for the queen. They make emergency queen cells, and then you remove them or destroy them and return the queen. And the artificial swarm returns to normal activity and makes no attempt to swarm. Logistics are quite important about this, and we have this little device that I thoroughly recommend. When you're moving the queen back, you want her really to go on the frame she's on, surrounded by her own mates, and we would because the colony is vertical, we have to, we can't really look in the bottom box because we're taking the top box off. So we find the queen first in the parent colony and pop her in this box, which we call sin bin. It's a bit like you have in ice hockey. She goes into there for a bit to cool her heels. And then we go into the lower part and deal with the emergency queen cells. So it's a useful thing. It's a useful piece of equipment for all sorts of jobs. If you are going to do any major manipulation of the brood area of a hive, it's a safer option to locate the queen and take her out. It's an alternative to putting her in a queen cage, but it's a lot easier and a lot less disruptive for her. We have had people who couldn't find the queen or forgot the date and to return the queen, and this is not the end of the world. What we're not quite sure of is if you don't repatriate the queen to the artificial swarm, will they use the multiple emergency queen cells to swarm? And we have from beekeepers who have either missed the date or just not bothered. We have slightly different testimony. Some people say that they don't swarm, and other people said that they have had them swarm. So if you accidentally do this, then it is probably a safety first to thin the queen cells in the emergency, in the artificial swarm. Yeah, but we're not sure on that. We haven't. Snellgrove 2 modified, it works reliably. Don't have to find the queen. Second manipulation, the queen's much easier. You have to get the timing right. It's not a disaster if you don't. You have to a quick change of plans, and instead of the artificial swarm being the main honey producer, the parent colony becomes the main producer. And you can let the artificial queen swarm requeen in its own time. I say this is why we think it works, is it switches the artificial swarm from swarming mode to emergency requeening mode. And we probably wouldn't have discovered this if we didn't use a split board. What do you do next with this colony? If you move forward 3 or 4 weeks, a new queen should be laying at the top. If you're doing this on a split board, you can now run this as a double colony with its own super for the rest of the season. And one of the earlier slides showed what you can finish up with a skyscraper, which can be difficult. Or you can remove the top colony to an outer apiary and give it independence. You can't do it in the same apiary easily because the flying bees know where they live and will try and return there. You can leave a decision until after the honey's been taken, and you can perhaps use, if the queen in the colony below is old, you could use it to requeen, or you could make it into an independent colony, or you could using a paper unite, you could use it to requeen another colony, just use the queen like that. There are all sorts of options open. So this is the same skyscraper again, which arises from keeping the colonies on top of one another. The problem of late swarming, unfortunately, preemptive swarm control can actually create the problem of late swarming. And you can manage to keep the colony together through May and most of June. Then in early July, you get queen cells just as the main flow starting, and this is very, very frustrating. We've been working on the best way to deal with this and have finally come to a solution. And we've tested it now for 3 seasons, and it has worked perfectly every time now. So we're pretty sure we recommend it. I don't think I'm going to deal with it because I think it's a bridge too far. But as I say, it's in the book and the booklets. So that's the end of the talk. So I will now come out of there, I hope. We can have a chat.
So yeah, I just had worry about the undeveloped queen cells and damaging them, moving them around.
Worry about them in what sense?
Joggling them around on certain days, right? They're not to be bumped or on some, I guess in the beginning and at the very end, I've been told that it was okay to move them, but on certain days, absolutely you don't want to be moving queen cells around because you might damage them.
What's the problem? I don't understand the problem. Do you mean the queen cells will come to harm?
Yes.
You mean through chilling or something like that?
No,
I
or
think
bumping
it's
them.
more along the lines of if you shake a frame that has queen cells on them, you might scramble them enough that they don't mature properly. For instance, if you're shaking bees off. So
scramble them. You mean shaking the frame or what?
shaking the frame to shake the bees off.
Well, we would, if we got queens. I don't believe queen cells are as fragile as they're made out to be. We would normally brush the bees off them, right? We carry a brush, and with queen cells we normally carry off. But I mean, I've shaken frames with open queen cells on. I got they seem to mature perfectly normally. I think you have to be a very energetic shaker to do any damage. And as for temperature, all brood is much more tolerant of brief periods of chilling than is made out. I mean, we have a culture in Britain where you should never open a hive until you can walk around just in a t-shirt. In other words, it has to be 16 degrees centigrade or more before you open a hive. We have opened hives in every month of the year, including under conditions when we've actually opened hives when there's been frost on the ground, and they come to no harm. As long as you don't linger and wave frames about, you can open hive. We've wanted to know what's going on in hives in the winter, whether they had brood or not, and things like that. I mean, we quite rarely we have a completely brood-free area at any time during the year. It may be a very small amount of brood there, but we've opened hives, and we've had hives that have had their roofs blown off, and they've stood there exposed to the element for days. We were left in charge of another beekeeper's hives for the winter while he was elsewhere, and he said he got a tenant who said would alert us if anything was wrong, and we went along to this apiary, and his apiary was in the foothills of Snowdonia, quite high up, and it had been raining and blowing for days on end, and we came to these hives and all the roofs were off and on the ground, and they were fully open to the elements, and they were actually, so the days when we had solid floors, not mesh floors, and the hives were not correctly on their stands, they were facing backwards, so they had a swimming pool in the ground floor, and we tipped these hive out and water poured out of the entrance of the hives, and then we propped them up so this wouldn't happen again. And we went to put the top boards and roofs on them, and these had been lying on the grass, and the grass was yellow underneath these roofs, and we thought, oh bloody hell. You could just hear a very faint soggy buzz inside these hives. That was all, and we just put them back together again, put some stones on the roof so it didn't happen again. And when he came back in the spring, we met him in about May and said, "How are your colonies?" He said, "Oh, they're fine. They're doing fine." And they must have been open to rain and wind for several days, and it certainly didn't kill them. So not had problems with this sort of thing. We have taken queen cells from apiary to apiary, in which case we would put them in something like that sin bin I just showed you. That's that box that takes a single frame, and we'd probably wrap a towel around them or something just to keep them warm. But I've never had any problems. Anybody else?
Yes, I have a question. When you are forming the artificial swarm, you take a frame with the old queen and move it to the new box, and then the flying bees will fly after the queen, and that's how you form an artificial swarm. Do I have that right?
Sorry, I didn't quite get that. It's your sound is not brilliant.
Let me try again.
Yeah.
Um,
Also, I'm not quite attuned to American accents, so keep going. You're probably not attuned to mine either.
I could speak with a British accent, but it would be false. You take the frame with the old queen on it, and you move it to your artificial hive. And because it's close to a swarm, the flying bees will go join that queen, and that's how you form an artificial swarm. Correct?
Yes.
And then later you will take that queen and you will move it back to the parent hive.
You're talking now about the Pagden method, are you? Which method are you? You're talking about an artificial swarm in which the queen goes with the flying bees. Yes?
I'm not sure. I'm not sure. I'm not sophisticated enough to know quite exactly what I'm asking.
Yeah, it's a bit to get your head round. I fully accept, and this is why. I mean, this is why the booklets are there, you know, to help beekeepers understand.
How can we get a hold of a booklet?
Well, you ask Jerry. I've had some correspondence with him about this, and we have discovered the books you can buy at a very favourable price if the association decides to buy a package of them. Of course, you can get them at bulk prices, and the carriage to America for a box of books is quite competitive, whereas single books it adds a lot to the price. You could if your association wanted to import some of the books, you could actually buy them off the association for a price lower than we charge beekeepers in this country. All the booklets are on the Wealth Beekeepers website, and there's free access to this, and you can download anything that you want from a whole number of booklets. There are 5 of my booklets there on different subjects. You can download any of them. the only problem is that there are queen cells in my hive. What should I do? Is perfectly okay to download without color, because there are no color-coded diagrams in, but the artificial swarming booklet contains a lot of color-coded diagrams that you would find difficult to comprehend without the color.
If I might interrupt, there is a link to the Welsh Beekeeper Association publications page in the chat. And you can look in the right-hand column of the publications page to find by name the particular document you would like to read. A lot has been drawn from those documents that has gone into the book. And the book also has material that I don't think is in any of those documents. So you have your choice. You can just rely on the documents from the webpage, or you can buy the book. And I think we're likely to opt to get a carton of the books and see how far they go among our members.
I mean, if you're going to try some of these methods, you do really need to have the diagram. Words are usually not enough. And the final stage of all this is to actually do it. And then you come to a different level of understanding when you've done these things. I've been there, got the T-shirt.
Half the battle is mastering the particular language.
Yeah.
Any other questions? Greg.
I do have a question. Wally, you use the term "we," as in we do this. And it sounds to me like your club does this as a coordinated effort. You do the same, you have all these independent beekeepers and you say, let's all do this thing and see what the outcome is. Is that how this is working? Because if my recollection is that you personally have about 8 hives or something, is that what you manage?
No. We have had up to 60. We've got 40 something.
Okay.
Yeah, we're down with the advancing years. We're downsizing. I mean, the reason we've
Wally keeps bees with his spouse too. She's a beekeeper as well.
We help her. A lot has changed in the last 10 years. Prior to 10 years ago, we had no teaching program in our association. And for the last 10 years, we have had a teaching program, a 2-year teaching program, which starts off with a course on beginners. And then we have a course in the 2nd year that's called improvers. And we take people right the way through to, first of all, it's just really just being able to handle bees, and when you open a hive, understanding what you're seeing there, all the different things that you can see there. And
I think you're off on a different subject. I think the question I'm asking is, when you say we, is this your own personal bees?
When I say we, my wife and I. I use the word we in a very democratic way, and my wife and I are partners in this.
Okay, so right. It's you and your wife's hives.
We have argued our way through these various things about what's the best thing to do, and we actually have a system between us that when we go beekeeping, we take alternate hives, and
okay, so we as you and your wife, not the club. Is that correct?
No, we have a training apiary where we train beginners. So that's with beginners, and we use our own apiaries for the improvers, because our apiaries are on the side of the island where they're more advanced in the year. And we also have, well, prior to COVID, we had apiary visits. We go to apiaries and look through their hives and discuss them. And the poor victim of this had to provide tea and cake.
Yeah, my question was, I was a little confused when you said we. Was that your personal apiary, or was that including the hives from your group? And
No,
it sounds
no.
like
all our sort of research, if you like, on colony management is done in our own hives, not other people's.
I got it.
And we've a lot of the beekeepers we have trained over the last 10 years, and my wife is the Anglesey Beekeepers Training Officer, so she organises all this. A lot of them use all these methods quite happily and have found them successful. And some of them just want to have a couple of colonies at the bottom of the garden and don't want to do very much with them. And this is why I say that, you know, beekeeping is a broad church. People get all sorts of different things from beekeeping. Our main motive for beekeeping is we're both ex-research ecologists, and we're interested in the bees themselves. And we make honey, and we sell honey, and we make a bit of money in good years. But that's incidental, really.
So I have another question, if I could. It seems like what you're doing, in short, is you're essentially moving the hive, the hive that's about to swarm. You move it off to the side. You put a hive with a cap brood frame in the original spot. 10 days later, 9 or 10 days later, you move the queen from the swarming hive back to the original hive spot, and then what happens to the hive with all the swarm cells? Is it makes a queen, right? Is that what you're doing?
I think you'd have to look at the diagrams.
Well, I was trying to, but it seems like I got lost on there.
Yeah,
somewhere.
okay. I can sympathise. I've read articles with these things, and you have to really sit down and look at it to see what actually they're doing. The artificial swarm always stays in the same spot, which is on the original stand, right. And that is simply because you need the flying bees to go there because they contain these swarm organizer bees, right? And they're the ones that you're trying to persuade not to swarm. And that can be done. It can be done on 2 separate hive stands. It can be done vertically. There are advantages in both. And in the method 2 modified that we suggest, the queen initially goes in the parent colony, which is in a different position, and that's why it loses the flying bees. And then after 9 or 10 days, the queen is returned to the artificial swarm, and because it has because it has emergency queen cells in it, it's expecting to have a gift of a new queen in the next few days, and the fact that it actually gets a mated laying queen doesn't seem to worry them in the least bit. They just carry on with life as though.
Well, actually, if you put, but it seems like you've put in your artificial swarm box that's now in the original location.
Yep.
You've put only capped brood. So how is it going to make any?
No, we don't put. No, you must put brood from which they can make emergency queen cells. In the Pagden method, the one I first described, it does have to be sealed brood because they're not supposed to make queen cells. But the breakthrough was the fact that the artificial swarm had hope for the future, that it was just in a queenless position, but had the means of recovering. And that's what turns off the swarming impulse. It gives that colony a different priority, which is to get requeened as quick as it damn well can and not swarm.
Greg,
Okay,
I read through the
on the-
book and it was confusing for me the first time. Hearing Wally say and show the diagrams has made it more clear to me.
Yeah.
I think it's just a case of.
So the
taking it out of
artificial
the book.
I just see that what you've done is, okay, so your artificial swarm, you've given it, now you're saying you put it in with brood they can make a queen out of. Now
Yeah.
you go through and you kill all the queen cells,
Well,
and then you drop the queen in there. And so
okay, carry on.
you don't have to kill all the queen cells, I guess, if they're not capped right. Because as soon as you put the queen in there, they probably will either kill them, or maybe she'll kill them even if they hatch, right? But then what happens to the swarm box, the original hive that you moved away? That's got numerous queen cells in it still.
Yeah.
Right?
Yes,
So
it does.
that could do multiple swarms, right?
No.
Or will it not?
Don't forget, because it went away with the queen in it, and because they've lost the swarm initiator bees, they then, after a day or two, as those queen cells start to mature, the original swarm cells, as they start to mature, they realize that they have these new queens available to them, but they already have a mated queen there, so they just destroy them, right? And they do it absolutely reliably, and
wow.
Yeah, you actually have to let them.
So basically, right. So basically, just by moving your hive that's going to swarm, moving it away to somewhere else, you've taken all the bees that want to swarm, you've taken those away, and now the bees that are left there will kill all the queen cells. Is that what you're saying?
Yeah,
all the swarm cells.
And you actually have you actually have to let them make this decision themselves. We had a bright spark who thought that, oh well, why don't I just destroy these queen cells now, save them the bother, and that completely upset the whole thing. They have to make this
they have to actually go through the
have to go through the process.
You have to let them.
Yeah. As I say, it depends how many days it takes them to do this, depends on the maturity of the queen cells that you put there, because it's not before day 11 that they will destroy them. And that's when they become fully aware that there are queens in there.
So that's on day 11. So that's, wait a minute, but you've moved the queen on day 9 or 10, haven't you?
Yeah, but don't forget the queen cells are all that. If it's got charged queen cells, they'll be the minimum of 4 days old already. Right? If they're sealed already, then they will be at 11 days in only 3 days, won't they?
So we're talking about two different clocks here. One is the clock of the age of the queen cells, and the other is the calendar between the interventions.
Yeah, and if you have made if we've done this artificial swarm when the queen cells were very young, then it is actually a close call that they tear the queen cells down before the emergency queen cells in the artificial swarm start to emerge. So you've got to get the timing absolutely right. So we have gone on day 10 to a hive and the cells have not been torn down, and we had to leave it another day for them to be torn down before we could complete the operation. And they were torn down in the next 24 hours.
So you wait for the original swarm cells to get torn down before you move the queen out? Is that right?
Correct.
In normal circumstances, it's done by day 9 or 10. It's only the exception where the queen cells were very early stage that they won't be torn down.
So if all the swarm cells are torn down in the original hive, not the original location, but the original in the swarming hive,
Yeah.
how does that hive requeen? How does that hive requeen itself?
Because in the meantime, the queen in there during her 9 or 10 days stay there has resumed laying, and there will.
I got it.
She starts to, once the swarm initiating bees have gone, she starts to lay, and with increasing amount of laying over the next few days. So there'll be several frames in there that contain eggs and young larvae when you remove her again. The alternative to that.
Then you're hoping. So that'll be an emergency requeening on that hive.
Yep.
Right. Okay. But now, have you ever seen multiple swarms coming out of an emergency requeening situation?
No, never.
So subsequent, never.
Never.
There's only really okay.
A colony that's
actually that's very clever. I like that.
I have seen a colony emergency requeening with over 50 queen cells, and they make no attempt to swarm. The behavior towards the queen cells in an emergency situation is quite different to that in a swarm, in the fact that the worker bees themselves are shown to have destroyed over 50% of those cells before they even get to maturity. David Tarpey has done a study on this recently. It's in the literature. One of your bee researchers in America, he's done a study on this. And the bees behave entirely differently towards them.
Okay. Yeah, so the only thing I don't like about your over-under situation is I think you need to hire a couple basketball players to make that stack work, right?
Yeah, well, yeah. It is a problem, yes. Two of us manage it. Two of us manage it fine. If we had the good fortune to have an absolutely marvelous season where the number of supers, we have had seasons where we've had 7 supers on a hive, and if you also had a double colony like that, it would be a danger to low-flying aircraft. In years like that, we would take an intermediate crop of honey. We would take a crop mid-season. We have had one season where we took 3 different crops at different times. We took a spring crop.
Yeah, it seems like this would be a problem if you have a lot of honey on your hive.
Yes,
you really wouldn't want to be doing a lot of this with honey on your hive because it's pretty darn heavy. And
yeah. I mean, I don't know what size boxes you use for your honey. Do you use deep boxes for your honey?
Generally, no.
Personally, no. No. Some people do, but
yeah,
I'm at an age now where I don't think I want to be handling a
I have helped out harvest honey in New Zealand with a beekeeper who used deep Langstroth for his honey, and I do know what a problem that is.
Yeah, it's really
yes. I mean, well, the shallow boxes we have are probably very similar to the weight of yours. A box full of honey, absolutely full, weighs about 40 pounds.
Ours will be, I think, 60 to 70 pounds of honey on one of our medium Langstroths.
Right. Okay. Yeah.
That
is for elderly people such as myself. That is a problem, and I'm not sure it would have been a problem
for me. I guess it's a problem for me. I maybe that puts me in the elderly category too then. But the only thing I like about deep harvesting from deep frames is you get more honey off a single deep frame than you do off of 2 medium frames. So it is very rewarding to harvest deep frames.
Yeah. I mean, in fact, our honey extractor it's only big enough to work radially on small frames. We have to, if we have any deep frames of honey, we have to use the tangential alternative. We have to put screens in our extractor and do them tangentially, which all takes more time.
Okay, well,
but having a lot of honey to extract is good news. We're prepared to put up with a few inconveniences to have a big crop of honey.
Well, this year, some of the people in our area have been harvesting. I mean, we have people harvesting in October and November.
Yeah.
And yeah, it's been a very strange year. And I'm kind of afraid that I haven't been in my hives in a few weeks here, but I see them bringing a lot of stuff in right now. And so I'm afraid that when I go in there, I'm going to be seeing brood areas that are just backfilled with honey, and I've got to have to pull all that out.
Right.
I like that method. That's kind of a neat method what you're doing. It's a lot different than the on-spot splitting, you know, where you leave the original hive in the original location. This year actually moved the original hive to a different location, which is kind of an interesting idea. And then if I'm summarizing it correctly, that loses all the bees that normally would swarm, and then they take down the queen cells, and then the original hive you put the queen back in there, but before you're in there, you have to take out all the queen cell. Oh no, they'll kill her. They'll kill all the queen cells because they've got their queen back, right?
I don't know. It's not something I've done. I don't know what the behavior would be in those circumstances. I can't tell you. So
I thought that's what you said you do.
You're possibly right, but I don't know.
Oh, so you do go through and take out all the queen cells.
We take them out.
Formed.
If we want the colony that makes emergency queen cells to have plenty of nurse bees, but since you in the parent colony you have taken most of the nurse bees away, we are slightly cautious about the quality of these emergency queen cells, whether they've actually been enough nurse bees there to feed them properly. However, I think we've possibly been overcautious with this, and we have recently gone more to using these queen cells that were raised in the artificial swarm. We put them in the parent colony so they don't don't have to go through the whole process of making their own emergency queen cells,
I see.
which would delay requeening of the parent colony for 9 or 10 days. So we quite often use, judging on the quality of the queen cells, visual quality, we will use them to requeen the parent colony. But we are cautious.
I didn't catch that aspect. So you take the emergency cells that were formed in your swarm, not in your artificial swarm, and you put those back in the original hive. Is that?
Yeah.
Wow. So that saves several days.
Saves 10 days, rough. Saves 10
3
days.
or 4 days. Yeah. Wow. That's really good. Interesting. I have to think about that a little more, though. That's really good. I like that.
No, you have to do it, mate. That's the only way you really get your head. unless you've got a.
Yeah,
a much-
the only problem. Yeah, I understand that doing it is a lot better than just thinking about it, but I'm not so sure I really want to wait for one of my hives gets ready to swarm. But maybe I won't have a choice this year, so
Yeah.
it'll answer itself for me, but it's a good thing to try. I think I'll do that this year. Thank you. I appreciate it.
Okay.